In this video, we'll learn to count up to 100 items. I have a number of 1-pence coins on the board. I'll count them all. So I'll start from the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. So I have 100 pennies or 100 pence. This is a skill. Counting up to 100 items is a skill that you need to master, and it's going to help you with next steps, because in everyday life we need to count items, especially money, but it could be other objects around the house, it could be parcels that you receive, or anything that you've got to deal with at work. So it's really important that you practice doing this and you learn how to count up to 100 items. In this video, we'll learn to count up to 100 items in twos. I have a number of 2p coins, as you can see on the camera, and I'll count how many I have in total. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100. As you can see in the pattern, the same thing, or almost the same thing, is happening in all the rows. We've got 2, 4, 6, 8, 10. We've got 12. So all we have changed is the 10 in front. and then 22, 32, 42, 52, 62, 72, and so on. 4, 14, 24, 34, 44, 6, 16, 26, 8, 18, 28, 10, 20, 30, 40, 60, and so on. So it's the same pattern. You leave in a gap, you continue with the next number. So 2, 3 is missing, then you have 4, 5 is missing, then 6. And that is repeated in all of the rows, in all of the numbers up to 100. The same thing continues after 100 as well. So you might want to explore that. So you might be given in a question a number and then count on in twos from that point. So let's say we have 46. So then you'll do 48, 50, 52, depending on how long the sequence or the pattern needs to be. Or you might be given 48, then 50, 52, 54, and so on. So it really depends on where you're starting. Another way, or another question you might see is maybe being given 13. So that is not in this sequence, that's missing, but you've got to count on in twos from that point. So 13, you leave 14 out and you go to 15. 16 is out, then 17, 19, 21, and so on. So another one, let's do another one of these. We've got 55, then we'll go to 57, 59, 61. So you should be able to pick up from any point really in numbers up to 100. So when it asks to count in twos, it means you leave one out and you start on the next number. Try practicing this with numbers, with coins, whatever you might have, objects around the house, and count in twos. It's a good one to use 2p coins because that's their value, 2p, or you could do it with pairs of socks, or any other pairs. In this video, we'll learn to count up to 100 items in tens, so in blocks of 10. I have a number of 1p coins here, and in the first row I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10p in the first row. It's the same number in the second row and all the other rows, so I've got 10p in each of them. So I need to learn to count up in tens, so going up in tens. 10 and another 10, that makes 20. Then 30, 40, 50, 60, 70, 80, 90, 100. So this is a quick way to count all of these rows of 1p coins. On the other side, I've got 10p coins. So that would be in total 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that is again the same amount. So the coins that I have on the right have the same value as the coins, all these coins that I have on the left. So we should be able to count them in ones, to count them in tens, in rows of 10 or 10p coins at a time. Practice doing this with coins that you might have, as it's an important skill. In this video, we'll learn to represent numbers up to 200. We use numbers in everyday life in many contexts. We use to count many objects, shopping items, if we buy lots of, or most importantly, money. I'll use the context of money to explain and show how to represent numbers up to 200. So I have this amount of money. How much is that? That's £22. What does that 2 mean? As I said, £22. So that is £2. And this means 20. So there is 10 and another 10 to make 20. So this is representing the single pound coins, or as we call them, the units. And this is representing the tens of pounds. We call that the tens. So what would we do if we had a few more pounds? And let's say I've got this many more. There we go. 2, 3, 4, 5, 6, 7. So that means that I need to change the 2, this 2, to make it a 7. Do I change this over here? No, I don't, because I haven't added any £10 notes. Or it hasn't, all these coins don't add up to 10, because that's the point when we transfer them over. So let's suppose I add another £3 coins. So I've got 7, there's going to be 8, 9, 10. So I've got 10 in total. This means now that this is worth a £10 note, and that's going to go into the tens. It's not a unit any longer, because units go up to 9 only. So I will collect these £10 notes and I will transfer them or convert them with this £10 note. And do I keep it here? No, it's got to go to the tens, not the units. So now the amount of money that I have has changed. I have 3 tens and no units. I haven't got any coins in this column, so I've got £30. If I added this amount, then I would have 50. So again, I'll change this in 3 into a 5. If I had this amount, right, so I'm having the 5 here, although it's a note, its value is less than 9, so it's got under the units. It's not a 10 yet. I can't make a block of 10 to transfer to the tens. So it is a unit because I've got 5, 7, 8. So this needs to change to 8. So altogether I've got £58. I will now use cubes to represent the same amount. So I'll take away the money and I'll represent this amount using cubes, and I'll take away the pound sign. So this is telling me that I got 8 units. So I'm gonna add 1, 2, 3, 4, 5, 6, 7, 8 single units or single cubes, and I've got 5 tens, so blocks of 10. By putting all of these 10 of these together, I can get the block of 10 like this. So there is a 10, and there is another 10, and 3 more. All together I've got 5 blocks of 10, which makes 50. So this again represents 58 cubes. If I had a few more of these, that make 60, 70, 80, and another one that makes 90. So 9 blocks of 10 will change this into a 9. So I've got 98. If I add 2 single cubes, what would happen? Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've said that if we've got 10, we could actually put these together to make a block of 10. So I will add these together. I'll put them together. So now we've got a new block of 10, which can or should join the 10s. So there are no units, no single cubes. But do I still have 9 10s? There are actually 10. And again, just like with the units, if you've got a block of 10 of them, it's got to move to the next column on the left. So this now represents 100, so it's a 100 block. I can't have it here, so it's got to go to the hundreds. So there is a block of 100. We'll call that hundreds. And are there any 10s any longer? No, they're not. So that needs to change now to a 0. And that's number 100. So I've got a block of 100, no 10s, no units. Whereas now I have a block of 100, a block of 10, and a block of and a unit, a single unit. So 1, 1, 1. So this one represents the units, this one represents the 10s, and this represents the hundreds. If I had 120, so I will change the number to 120. Oh, I want to represent 120. What does this tell me? There are no units, but there are 2 10s. Why do I keep the 0 there? I need to keep it because otherwise the number would read as just 12, and that has a different value from 120. So we've got to have that 0 in there. What would I do to represent the number 105? So 105. That suggests that I've got 5 single cubes. 1, 2, 3, 4, 5. And I've got no 10s. So this is how I represent 105. And finally, how would I represent 200? How could I show 200? So 200. That suggests that there are 2 blocks of hundreds. So I will bring over another block. There we have 1, 2 blocks. Do I have any 10s? No, I don't need any 10s, and no units. And this is how we represent numbers up to 200. In this video, we'll learn to read numbers up to 200. I've written down the numbers from 1 to 100 in this square, and from 101 to 200 in this square. I'll read these out to you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Up to this point, you should be able to do these already at this level. Now moving on, we've got 21. So just one on top, there is 20 in front that we've just done. We add in one on top, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. 101. Just like the one here, we add an 100 on top, 101. 102, 103, 104, 105, 106, 107, 108, 109, 110. 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, 130, 131, 132, 133, 134, 135, 136, 137, 138, 139, 140, 141, 142, 143, 144, 145, 146, 147, 148, 149, 150. 151, 152, 153, 154, 155, 156, 157, 158, 159, 160, 161, 162, 163, 164, 165, 166, 167, 168, 169, 170. 171, 172, 173, 174, 175, 176, 177, 178, 179, 180, 181, 182, 183, 184, 185, 186, 187, 188, 189, 190. 191, 192, 193, 194, 195, 196, 197, 198, 199, 200. So I've counted all the numbers up to 200. What did you notice from when I read these numbers and the ones after 20? So again, the units are repeating themselves. That one is appearing here and again. So 1, 11, 21, 31, 41, 51, 61, 71, 81, 91. So every time it means you've got 20 and an extra one, 30 and an extra one, 40 and an extra one, and so on. Same thing over here. We've got 2, 12, 22, 32, 42. So it's the 2 extra, the 2 units. So if you've got £12, it's a £10 note and £2 coins. £22, it would be £20 and the two pound coins. So that is appearing again and again. So if you know how to read numbers up to 20, you are okay to read all of these other numbers. So as long as you know 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100 is the same pattern repeating itself. Then moving on to numbers over 100, we can see that again all that we have on top is 100. So 1, 101, 2, 102, 3, 103, 11, 111, 12, 112, and that is being repeated all the time. So if I want to represent 111, how does that look like in practice? What does that mean? It means 100, so I've got a block of 100 cubes in here, and 11, so then a block of 10 and one single cube. So 100, 10 and 1 makes 111. So that one represents this block. This one in the middle represents this block of 10, and the last one represents the single cube. So 112 is going to be 110 and the 2, 113, 110 and the 3, so 113 looks like this. Now if you look at, for example, 134, how is that going to look like? So 100, we have that 100 there. Do I have 30? I actually have just 10, so I'm going to need, that makes 20, it makes 30, and is that 4? No, it's 3, so I'm going to need another single cube. And I do the same thing. Let's say 154 is going to be 100, I've got 30, I need another 2 blocks of 10. So there we have 40, and we have 50, so 150. So in 154, I've got 150 and 4, 154, up to the point where we have 200. So how do we represent 200? I could count on these, so I'd make 10 blocks of these and no single cubes, but the easiest way would be to have another block of 100. So there I have 100, and this one makes 200, so I don't need any 10s. So, and no single cubes as well. So that will be 200. And this is how to read numbers up to 200. In this video, we'll learn to write numbers up to 200 in digits and in words. So I will start off with numbers bigger than 20. You should be able to know how to write numbers up to 20. If not, go back to the entry 1 video on writing numbers up to 20. So it is important that you know how to write all the 10s. 10, which in words is written as TEN. 20, 30, 'So different from 4, which you write as FOUR, you write 40 without a U. 50, Again, different from the 5, you write this as 50 with an F in there. 60, that doesn't change. 70 doesn't change either from the 7, just add the TY at the end. 80, 90, 100. Two hundreds. So 2 lots of 100, which makes 200. So 10, you should know 20, 30 comes from the 3, but you write it as THIR and then the T at the end. So we see the TY appearing up to 90, just as we say the words 90, 80, 70, 60, and so on. 100, 100, and 200s. Now, as we said before, you should know how to write numbers like 1, 2, 3, 4, 5, up to 20. So if you want to write 22, for example, you would write it as 22 in digits, and in words that would be just the 20 and the 2. If you want to write 56, so write the 50 and the 6. If you want to write 68, so 60, 8, 79, 70, and the 9. If you want to write 135, so we got 130, so 3 tens and 5 units, 135. So you can say 100 or 130. So we've done the 100, we've done the 30 and the 5. If you want to write 156, so we've got the 56 there and we've got the 100 there, so we're going to write 100 and 56. 56. Let's say we want to do 168. 168. So 100 and the 68. So we can say 100, which is the same as 1, and 68. So we've got to see where are these all located. Let's say 179. What represents them, or what do they represent? And as we've looked at these before, this means the units, this means the tens, and this means the hundreds. So there is 100, so 100, 7 tens, 70, and the 9, so 179. Whereas this 108, because there are no tens, so we'd read it as 108, because there are 8 units, 100, 108. How would I read this? This would be 120, because there are 2 tens but no units. Whereas this would be 121. And how would I read this? 199, and that's how I write it when I hear somebody saying the number. If somebody says 199, you've got to listen to what are they saying. So I'm gonna say now another number. It's 166. So I'm saying 100, so there is 100, and 60, so there are 6 tens and 6, so 6 units. So hundreds, tens and units. This is how you write numbers up to 200 in digits and in words. In this video we'll learn to order and compare numbers up to 200. I've got 43, 29, 76. I'll order these numbers starting with the lowest, the smallest. Which one is the smallest? If I look at these numbers, I've got 43, which is 4 tens and 3 units, so 43. 29, so 2 tens and 9 units, and 76. Which one has the greatest value? It is the tens that have the greater value. So I look for the one number that has the lowest number of tens, and that is 29, because it's 2 tens and 9 units. So I'll start with 29. Then the next biggest one would be 43, because it has more tens than 29 but fewer than 76. So 76 would come last because it's the biggest. And what I can say if I'm to compare these numbers is that 43 is bigger than 29. So 29 is smaller than 43. "29 is smaller than 76. Whereas 76 is bigger than 29. Also, if I want to compare 43 and 76, I can say 43 is smaller than 76, and 76 is bigger than 43. So I've compared and ordered these top numbers. Now look at these ones, which are bigger. So I've got 130, 82, 103. What I will do is order these from biggest to smallest. So from the biggest to the smallest. So when I looked here, I wanted the smallest to biggest. So I looked at which amount, if this was money, which amount would I least want to get first? So 29 is the one that I would least want to, because it's the lowest amount. And then finally you'd get to the one that you want most, 76, because it's the biggest. Whereas here, the biggest, the highest amount I would want first, I would want to get. So I'm looking at the one that I'd mostly want to have. And if I compare them, I wouldn't want that first because it's 82. So it's 8 tens and 2 units. It hasn't got any hundreds, so it's less than 100, whereas these two are bigger than 100. This is 103 3. So £100, for instance, and £3, whereas this is 130. So here I would get £130. So this is the highest amount out of the 3. So I'll do 130. Then would come 103, and finally 82. That's the smallest one. Now, if I want to compare these, I would say that 130 is bigger than 82. $130 is also bigger than 103. And if I am to compare 82 and 103, I'll say that 82 is smaller than 103. 103 is bigger than 82. 130 is bigger than 103. 103 is smaller than 130. So this gives you examples of how to order and compare numbers up to 200. In real life, you'd need to compare maybe prices of different items. Would you want the cheapest or the most expensive? Or the cost? You know, is it more expensive to rent a house for a year or rent another property for a year? Which one would you prefer? In this video, we'll learn to recognize and sequence odd and even numbers up to 100. Odd. In real life, we come across the word odd in examples like odd socks. And that's exactly what it means. And even is like the pair. So I've got some socks here. There is one and another one. So I have 2 socks. With these 2 socks, I can make a pair. So number 2 is even. Then I have another sock. Can I make another pair with that? No, I can't. So number 3 is odd because I could make a pair, but there is still one left. There is another sock. Now I've got 4 socks, but I've made 2 pairs, so there is no odd sock. There is no sock left, which means that 4 is an even number because I can make pairs and have no odd socks left. Whereas 5 is odd because I have an odd sock left. I hope you can see the pattern. So I will write the numbers. So as we said, odd, even. So that's the odd socks and that's the pairs. So when we had just one was odd, but 2 socks made a pair, so there was nothing left. So 2 is an even number. Whereas 3 was odd again because we could make a pair, but there was a sock left. And 4 is even because we can exactly make pairs. We can make exactly 2 pairs. And 5 is odd because we have an odd sock in there. Now what would happen with 6? So 6 would be even because we can make 3 pairs. 7 would be odd. 8 would be even. 9 would be odd. 10 would be even. So if you look at these numbers, we start with 1 if you have 1 sock. That is odd. And then missing 1 to go to 3. So that means you still have an extra sock. And again, they're 7 and 9 as well. Whereas with these, we've got 2, 4, 6, 8, 10. We've seen these numbers before when we counted in 2. And again here you're counting in 2 as well. But when you have 2 socks, it means you have an even number. So that, I hope, helps you with the pattern, because the same thing continues. So then it would be 11, 13, 15 and so on, and here would be 12, 14 and so on. Now let's see what happens with numbers that are bigger than these. If you look at the numbers, the odd numbers, 1, 11, 3, 13, 5, 15, 7, 17, 9, 19. So the unit is staying the same. So you can now predict what's going to be the next one. So we've finished there. It's going to be 21, 23. So the unit is all the time the same. So if the unit is odd, so will be the whole number. So 3 is odd, 23 is odd. So you just need to look at the unit. And why is that the case? If you look at 11, for instance, so 1 is odd, 11 is going to be odd. So you can imagine there being socks. So 1 sock, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 socks. But what's going to happen? Going to make a pair there, 2, 3 pairs, 4 pairs, 5 pairs. So with the 10 in there, we making pairs. So we've got them even. It's only the extra one that makes it odd. Same thing would happen with 13. So with 12, you're going to make pairs. So there is an extra pair in comparison to 11, and that is just extra. So we'll see exactly how that looks like for even numbers as well. So if you've got 2 and then you've got 4, 6, 8, you can see mixed pairs always. 10 mixed pairs, 12 mixed pairs, of course 13 doesn't, but 14 will make pairs, 16 will make pairs. So the same thing as with the odd, you look at the 2, at the 4, 6, 8, look at the unit, yeah, so 0, 2, 4, 6, 8, 2, 4, in 16 as well, 18, 20, 22. So if the unit is even, the whole number is even. And how does that look like in a number grid? So I've got a number grid here with numbers from 1 to 100, and as you can see, 1 is odd, 3 odd, 5, 7, 9 is odd. So the blue ones are odd, whereas the white ones are even. So So all these numbers that we saw here, 1, 3, 5, 7, 9, then we have 11. So in this column we've got numbers ending in 1, or that the units are 1. They are odd. So are all these ending with 3, and ending with 5, 7 or 9. So these numbers in the columns that are colored in blue are all odd, and the numbers in the columns in white are all even. So all we need to do to find out whether a number is odd or even is to look at the units. So let's say I've got number 32. What do I look at? It's the unit. The number 2 in itself is even, because we can make a pair and we have no socks left. So that means number 32 is even. Let's check it here. We've got number 32 and it is even in the white columns. Let's say number 45. Look at the unit, that's a 5. So 5 is odd, so number 45 is odd as well. Let's have a look. We've got 45 and it is odd. So all that you have to do is really look at the last digit, look at the unit. If the unit is 1, 3, 5, 7, 9, then the number is odd. If the unit is 2, 4, 6, 8 or 0, then the number is even. In the previous video we looked at these 3 symbols: add, subtract and equal symbols. In this video we'll look at these other 2. So this symbol is the times symbol. So 2 times 3 equals 6. So that's how and when we use that symbol. Another word for it is the word multiply. Multiply. So 2 multiply 3 equals 6. And also lots of. 2 lots of 3 give me 6. So there is 3 coins I have, so there is 1 lot and another lot of 3. That altogether makes 6. Then is the divide sign or symbol, which also means to share equally. And to split an amount. So let's get an example. Now we have that 6 divided by 2. So if I have, again, 1, 2, 3, 4, 5, 6 coins, and I'm gonna split them or share them equally into 2 parts, then I'll have 3 in one and another 3 in another, so they are equal, 3 and 3. So the answer is 3. So this is what times and divide mean. And if you need to refresh, add, subtract and equals, go back to the previous video. In this video we'll learn to add 2-digit numbers. In everyday life we need to add 2-digit numbers when it comes to money, when it comes to adding different items all together. And 2-digit numbers are numbers like 24, 38, 14, 99, because they have 2 digits. So 24 has a 2 and 4 2 digits. 38, that's 3 and 8. 14 is 1 and 4. 99 is 9 and 9. Whereas 8 is a 1-digit number because it has just 1 digit. 103 is a 3-digit number. So we'll focus on these ones, the 2-digit numbers. I'll add 2 different amounts here. I've got 13, so I've represented it with this, that there is 10 and 3. So there is the 3, the single cubes, and 10, which is represented through this 1, meaning 1 block of 10. Plus, I'll add to it 25. So I've got 13 add 25. So 25, there are 2 blocks of 10 and 5 single small cubes. How much or what does this add to? So I'll start adding the cubes, the units, because I might be able to make a block of 10 with them and transfer them to the tens. So let's see, what do I have? So I've got, when I put these together, I've got 1, 2, 3, 4, 5, 6, 7, 8. So that makes 8. So the units make 8. And when it comes to the tens, I've got a block and another 2, so that's 3 blocks of 10. So the answer is 38. So all together, this is 38, which is represented by the 3 blocks of 10. So this 3 is represented by the 3 blocks of 10, and these 8 represent the 8 here, the units. Now I will look at another example. I'm going to add 42 and 39. And we'll work out the answer. So I'll represent 42, 4 blocks of 10, represented by this 4 here, and we've got 2 single cubes, the units. And 39 is represented by 30, so 3 blocks of 10, and 9, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll try and add them, starting again with the units. Let's see, can I make 10 with these? So I've got 9 already in here, so I'll try and make with the rest of them a block of 10. So I've got 5, 6, 7, 8, 9, got 9, and another one that makes a block of 10. So I've made a 10 which I'll need to transfer over to the tens, and what is left from the units, there is just 1. So I will put a 1 here for the units. Now I've got a spare or an extra one, a left one, which I like to write here at the top. So that is represented by this. So let me count. I've got 1, 2, 3, 4, 5, 4 and the 1, 5, 6, 7, 8. So this is represented by the 8 here. So all together 42 and 39 makes 81. So if we go back to it now without the cubes, we've got 2 and 9. When you add together, that makes 11. So I put the 1 from the 11, the units 1 there, and I carried over the tens. So 10 goes up there and the 1 stays there. So there we've got 10, and the 40 makes 50, and the 30 makes 80. So 81 altogether. I'll do just one more example without the cubes. So I've got now 58 plus 34. So I've got 8 and 4, that makes 12. So I'll put the 2 down and the 10 goes over there. So in this 12, when I added 4 and 8, 12, I'm keeping the units here where the units should be, and this one, which represents the tens, goes to the top. So I've got 5 and the 1, 6, and the 3 makes 9. So 58 and 34 makes 92. Let's just do a final example. So we've got 15 and we're going to add to it 27. We've got 5 and the 7 makes 12. So I'll put the 2 down in the 12 and I'll transfer over the 1, which represents 10. So 1 and 1 makes 2 and the 2 makes 4. So that is 42 that I have. This method is called the column method, but there are other methods as well, which I'll go through. In this video, we'll learn to add 2-digit numbers using the partition method. As the name suggests, partition is about breaking numbers down into parts, and I'll show how. So we've got here 13 and 25. 13 can be broken down into 10 and 3. So tens and the units separated. 25 is broken down into 20 and 5. Now it's easy for me to add the tens together. So we've got 10 and 20 makes 30. 3 and 5 makes 8. So 30 and 8 makes 38. Let's look at another example. We've got 42 and 39. So 42 is broken down into 40 and 2. 39 is broken down into 30 and 9. 40 and 30 makes 70. 2 and 9 makes 11. So 70 and 11 is 81. So this is how to use the partition method to add numbers. In this video, we'll learn to add 2-digit numbers using the number line method. I've got 13 and 25. I'm going to add them together. So what I'm starting with is the number 13. What I will do, I'll break the 25 down in my head into 10 and 10 and 5. So I've got 13. If I add 10 that makes 23. So that's gone. If I add another 10, that makes 33. So that's gone as well. If I add 5 now, that is going to be 38. So I've added all of them and my answer is 38. Now we'll look at another example. So we've got now 42. So we're starting with 42. I'll add to that, there's 10 and 10 and 10 and 9. So I'll add 10 to make 52 and another 10 to make 62 and another 10 to make 72 and 9 to make 81. And that gives me the answer. So this is how you use the number line method to add two two-digit numbers. In this video we'll learn to subtract two-digit numbers. We use subtraction in everyday life, especially when it comes to money. So we have a certain amount or a budget and we spend some money. So when we need to work out what we have left, we use subtraction. This is just one example, but there are many other examples in everyday life. I will use 3 methods to explain subtraction. One of them is the column method. I'll start off with that. So I've got 2 examples. 25 take away 13 is the first one. So I'll start by representing 25 using cubes. So I've got 2 lots of 10 and there are 5 single cubes in there. I need to take away 13 from that. So I'll start from the units because I may not be able to take away enough. And we'll see what that means. So I've got 5, I need to take away 3. There's 1, 2, 3. I've taken away 3, so that's left me with 2. So there is 2. Now I've got 2 of these sets of 10 and then I need to take away 1, so I'll take away 1. What do I have left is just one of them, so I'll make that a 12. So 25 take away 13 leaves me with 12. So let's recap. We took away 3 from the 5 and we had 2 left. We took away 1 from the 2 and we had 1 left. Now we've got 42 take away 19. So I'll do the same thing and represent 42 using the cubes. So I have 4 lots of 10 and 2 single cubes. I need to take away 19. So 9 to take away from 2. Am I able to do that? I can take away 1 or 2, but not any more than that. So what I will need to do is borrow a set of 10 or a lot of 10 from the 10s here, which means that I'll transfer this over to the units. So that has now become 12 because I've got 10 and the 2, that makes 12. So what is happening to the 4 now is that it has actually become 3 because we have only 3 lots of 10. So this 4 becomes a 3 because we actually gave 1 lot of this to the units, to the 2, which became 12. So now from the 12 we can take away 9. So we have 12. This one in itself is 10. So if I remove one of these, that means I'm taking away 9 and there is 1 left, 2, 3. So 12 take away 9 left me with 3. Now I've got 3 of these as shown here, and I'll take away 1. So if I take away 1, I'm left with 2, and I'll write that down. So my answer is 23. So let's recap what I did there. I had 42 take away 19. I tried to take away 9 from the 2, but there wasn't enough, so I borrowed 1 lot of 10 from the 4, so that became 12, and the 4 became a 3. So 12 now take away 9 gave me 3, 3 take away 1 gave me 2. So this is how you use the column method to subtract. I'll look at 2 more examples to illustrate. So we have 35 take away 26. So we've got 6 to be taken away from 5, but that is not possible because 6 is bigger than 5. So I'm going to have to borrow 1 lot from 3. So 3 becomes a 2 and 5 becomes 15. 15 take away 6 gives me 9. And 2 take away 2 leaves me with 0, and I don't need to write that number in front. So my answer would be 9. We'll now look at how to subtract 2-digit numbers using the partition method. So I will split 25 into 20 and 5, and 13 into 10 and 3. So 20 take away 10 leaves me with 10. 5 take away 3 gives me 2. So my answer is 12. Now I've got 42, which I'll split into 40 and 2. 39 into 30 and 9. I will now, if I take away 30 from the 40, that leaves me with 10, but I can't take away 9 from the 2. So I'm going to have to change this slightly. So I make this into 30 and 12. It still makes 42. Because then it's going to be easy to take away 9 from the 12. So 30, take away 30, leaves me with 0. 12, take away 9, leaves me with 3. So my answer is 3. So this is how you use the partition method for subtracting numbers. In this video we'll learn to subtract 2-digit numbers using the number line method. So we've got 25 take away 13. I'll start off with 25 and I will take away 10 first, because 13 is made of 10 and 3, so I'll take away 10 to go to 15, and then take away 3 to go to 12. So my answer is 12. Now I'll do the same with the 42 take away 39. So in my mind I've got 39, it's got 10 and 10 and 10 and 9. So I'll start with 42, take away 10, that gives me 32, take away 10, that gives me 22, and another 10, that gives me 12. Now from that I take away 9, and that leaves me with 3. So my answer is 3 for this. This is how you use the number line method to subtract. In this video we'll look at the times tables. So we'll start with a 0 and we'll end with 12. You can see a times tables grid on the screen, and we'll work with that. So here I'll share some tricks that will help you multiply. So I'd like you to have a look at the patterns within this grid. Look at the color, look at the numbers. What do you notice? Is it something that repeats itself? Are there any patterns in there? And you've probably noticed that anything multiplied by 0 equals 0. So 0 times 0 is 0, 0 times 1 is 0, 0 times 3 is 0, 0 times 4 is 0, and so on. 0 times 5,000 is 0, 1,000 times 0 is 0. And this repeats itself on this column as well, because it shows the same thing. It's 0 times 0 or 0 times 1 and so on. So the key thing for this part is that anything times 0 equals 0. And then we move on to the ones timetable. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 100 is 100. So it means one lot of something. So if you go once to the shop to get 2 items, you'll end up with just those 2 items. If you go 1 time to the shop to get 7 items, you'll end up with 7, and so on. So 1,000 times 1 is 1,000, 1 times 550 is 550. So in terms of this, anything times by 1 is equal, anything is equal to the number itself. So 5 times 1 is 5. Then moving on to the 2's. What do you notice? I want you to just stop for a few seconds and see if there is any pattern in terms of the 1's times table and the 2's. What happens to getting from 1 to 2? What happens? First of all, 1 add 1 equals 2, so, or 1 doubled equals 2. And also 2 doubled equals 4. 3 doubled equals 6, 4 doubled equals 8, 5 doubled equals 10. So really, the 2 times table is just double of the 1's. And that's not difficult to work out for any number. And of course, this repeats itself over here as well in this column, because this is the 2's timetable as well. And so we can say 2 times a number is equal to double the number. And moving on to the 3's. So we've got 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and so on. So you can work out 3's by going, okay, I want to work out 3 times 7, so I got 7, add 7, add 7, 3 lots of 7. So 7 add 7 is 14, and then the 7 is 21. And the same thing appears in this column as well, because we're multiplying by 3 here as well. So 3 times 7 is equal to 7, add 7, add 7. And looking at the 4's, so for a minute, let's jump from the 2's to the 4's and see if there is any connection between the two. And if you look at the 2 timetable, you will be able to see that it's half of the 4s, or in other words, the 4s are double the 2s, because 4 is double 2 as well, so 2 times 2 gives us 4, and of course that'd be the case here as well. So if I want to work out 4 times 8, for example, I can do 2 times 8, which is double 8. So double 8 is 16, and then add 16, that gives us 32. So that's a nice trick to use. And then through the 4s, we can go to the 8s, because again, you just need to double in order to go to the 8s. So look at that. From 4 we go to 8, from 8 you go to 16, 12 to 24, 16 to 32, and so on. So if I want to work out what is 8 times 7, so I can have double 7, which is 14, and then add 14 to get 28. So that gives me 4 lots of 7. All I need to do now to get to 8 lots of it will do add another 28, and that is 56. So that's how we get there. And of course, this is going to repeat itself for the 8th column as well. Okay, so let's now make another connection. So we did the 3s. What is the connection between 3 and 6? It's just like the 2s and the 4s, so it's double. So if you know your 3s, then the 6s are just double the 3s. So let's try it with one example. Let's say I want to do 6 times 5. So to get 3 lots of 5, I got, okay, 5 and 5, 10, and another 5, 15. So that's 3 lots of them. Double that, 15 is 30. So get the 3 and then double that to get the 6. So we've already done 0, 1, 2, 3, 4, 6, and 8. The 5s are what learners typically consider to be the easiest one, because you've got 5, 10, 15, 20, and so on. So that's not a difficult one to do. And moving on to the 9s, I'll skip the 7s for a minute. So there is a connection between the 3s, 6s, and 9s. As you can see, 3 and 3 makes 6, and another 3 makes 9. So if you want, you could do that. So you go 3. Let's try one out. If you know what is 3 times 4, then you get 6 times 4 by doubling that. So 12 and 12 is 24. Add another 12 to get to the 9 times 4. So that is just 36. But I also have a nice trick for the 9s, which I'm going to share here. So let's look at this. 9 times 1 equals 9. 9 times 2 equals 18. 9 times 3 equals 27. 9 times 4 equals 36. 9 times 5 equals 45. 9 times 6 equals 54. 9 times 7, 9 times 8, 9 times 9, and 9 times 10. 63, 72, 81, and 90. So what do you notice? The units, such as 9, 8, 7 in the answers, 6, 5, 4, so they go down by 1 every time. And the tens within the answers, like 1, 2, 3, so they're going up by 1 each time. So that's a nice and useful pattern for when you've got to do them in a row or write them in a column. But when it comes to you finding a random timetable within the nines, so let's say you want to work out what is 9 times 6. Now, if you look at the digits within the answers, so within the first one, we've got an answer of 9, so I can put a 0 in front because there's 0, 0 tens, just for showing this to you. So 0 and 9, if you add the digits, gives us 9. 1 and 8 gives us 9. 2 and 7 gives us 9. 3 and 6 gives us 9. 4 and 5, 9. 5 and 4, 9. 6 and 3, 9. 7 and 2, 9. So all of these, if you add the tens digit and the units digit, they add up to 9. So we know that the two digits will add up to 9. But also, when you look at the pattern, 9 times 1 begins with a 0. 9 times 2 begins with a 1. 9 times 3 begins with a 2. So it's 1 less. So if I want to work out 9 times 6, I can see that the answer will start with a 5, so 1 less than a 6. And I need a digit that when I add to 5 will give me 9. So that is a 4. So 54 should be the answer. And it works with all of these. So the 9s are okay as well. 10s, nice and easy, because 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30, and so on. And when it comes to 11, again, 1 times 11 is 11, 2 times 11 is 22. So that digit is repeated for the units as well. So tens and the units will have the same digit up to the point where you get to 110 and then 121. So 11 times 11, you can break one of these 11s down into 10 and 1. So then we'll do 11 times 10 first to give us 110, and 1 times 11, which is just 11. Add them together, so that gives us 121. And in terms of the 12th timetable, we've got to look at one example as well. So if I want to work out what is 12 times 12, so I will break down the 12 into 10 and 2. So I do 12 times 10 first to give 120, and 12 times 2, which is 24. So add them together and gives us 144. So that is pretty straightforward. So we've shared some tricks. The only ones that we didn't share a trick for was the 7s, but based on what we just covered, it works out that you only need to remember what is 7 times 7, which is 49, because the rest of the 7s is covered by other timetables, such as this one, for example. 56 is 7 times 8, but we looked at tricks for 8, so you should know how to work it out. Or the 9 times 7, for example, we looked at the 9 timetable tricks, so that should help work it out. In this video, we'll learn about the number of hours in a day and the number of weeks in a year. The day starts at 12 o'clock midnight, and then it's 1 o'clock at night, early morning, 2, 3, 4, 5, 6. It's probably time when some people wake up to go to work, school or college. 7, 8 o'clock again, early morning, maybe about time when you go to class, and then 10, 11, 12 is midday. That's time when you probably have lunch. So there have been 12 hours up to this point. Now in the afternoon we've got 1, 2 o'clock, 3, 4, 5, 6, 7 in the evening, 8, 9, probably time when you go to sleep, 10, 11, and we go back to 12 midnight. So there were 12 hours and another 12 from 12 midday to 12 midnight. So in total, in a day, there are 24 hours. Probably seen this information in shops which are open 24 hours a day. So there are 24 hours in a day. Now let's look at the number of weeks in a year. I have a calendar, and as we know, the year starts with the month January, then goes to February, March, April, May, June, July, August, September, October, November and December. This is the first week of the month, or the first week of the year, second week, third, fourth and the fifth. As we know, there are about 4 weeks in a month, 4.5. Whereas in total, for the 12 months, for the full year, there are 52 weeks. So that's an important number to remember. There are 52 weeks in a year. So 24 hours in a day and 52 weeks in a year. In this video, we'll learn to divide 2-digit numbers by 1-digit numbers. So 2-digit numbers are numbers that have 2 digits, like 12, 23, 35, 68. Whereas 1-digit numbers are numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So first of all, we'll share a method to divide 2-digit numbers by 1-digit numbers. I've got 24 cubes. I want to share them equally, because division means to share equally. Divide them equally into 2. So there I have 24, and I want to divide 24 by 2. That's the same as saying there would be 2 people sharing them equally. So I could create 2 sets or 2 groups, and there we go. I can put 2 10s in each of them. There's a 10 here and 10 there, so equal so far. Now I have 4, so I'm going to put 1 in each and another 1 in each of them. So how many does each set have? That is 10, 11, 12. So I've got 12 in each and every one. So I've cut them in half. I've created 2 equal parts, however you want to see that. What I will do now is use another method to divide the same number. So I've got 24 again. This time I'll use the bus stop method. So again, 24. I want to divide this by 2. So that means I'm creating sets of 2. For the 10s, which is represented by a 2 there, meaning 20, I want to create a set of 2, so 2 inside, and I can only create one set of 2. So I have 1, 2 in there. That's why I'm going to put 1 at the top, one set. With the units, how many sets of 2 can I create? I can create a set of 2 here and another set of 2 there. So there I've created 2 sets for the units. So my answer is 12, just like the other one that I had here. Let's try out dividing some other numbers. So I've got 48 and I want to divide it by 4. So how many sets of 4 can I fit into 4? That is 1, and there is nothing remaining. And then how many sets of 4 would I make into 8? That would be 2, and there is nothing remaining. But what happens if there are numbers remaining? Let's have a look. So now instead of 24, I'll get 25. So I've got 25 divided by 2. How many sets of 2 can I make with these 2? There's just 1, and there is nothing remaining. Now how many sets of 2 can I make with a 5? I can make one here and another one here, and there is a left. So I've got 2 sets and there is 1 remaining. Let's try out another one. So I've got 45 divided by 3. How many lots of 3 it fit into 4? That would be just 1. And I would have an extra one, a spare one. So that, let's actually show that using some cubes, how it actually looks. So we've got 40, got 45, so I've got 5 cubes. So how many sets of 3 can I make with these 40? I can make only 1, and I have 1 extra, 1 spare. So what I'm going to do with that is I'm going to put it on top of this, because now what I have is 10 and the 5 to make 15 in the units. So I will undo this to make groups of 3. Let's see. So I can make a group of 3. I can make another group of 3. So 3 and 3 make 6. And another 3 makes 9. And another 3 makes 12. And another 3 makes 15. So that fits exactly with the 15 we have. So there is nothing left outside of the sets. So we've got 1, 2, 3, 4, 5 groups. So our answer is 15. 45 divided by 3 equals 15. We'll now look at a few more examples of dividing 2-digit numbers by 1-digit numbers. I've got 78 divided by 3. So I'll look at how many 3's fit into 7, and that is 2, because 3 and 3 make 6, and that is just over 6, but it's not 9 yet. So if I take away 6 from the 7, there is 1 left. Now, how many 3s would fit into 18? And that is 6. And there is nothing left. So my answer is 26. Now I've got 66 divided by 5. So how many 5s would fit into 6? That is just 1, and there is 1 left. So that 1 is transferred to, that 110 is transferred to the unit to make 16. So how many 5s now would fit into 16? And that is 3, because 3 times 5 is 15, but there is 1 left. So I'll say remaining 1. So the answer is 13, remaining 1. Now I've got 87 divided by 6. So how many 6s fit into 8? And there is just 1 of them, 2 remaining. How many 6s would fit into 27? So 6 and 6 makes 12, and another 6 makes 18, and another 6 makes 24. So 24, 6 times 4 is 24, and there is 3 remaining. So I'll say remaining 3. Now I've got a couple of examples of division questions. There are 21 cupcakes, so that's an important thing to know. 21 cupcakes you have made. You put them in trays of 8. So you're going to fill the trays with 8 in each tray. How many full trays do you have? Let me divide to find out, because filling the trays or sharing equally means division, and there are 8 in each tray. So I'll go 21 divided by 8. How many 8s would fit into 21? So 1 is 8, 2 lots of them is 16, 3 lots is 24, which is more than that, so I'm going to stick with a 2. 2 times 8 is 16, so what I have left is 5, so remaining 5. The question is how many full trays, and that would be 2 full trays. 2 full trays, and I have 5 remaining, 5 cupcakes remaining, but I'm not asked about that. I'm asked about the full trays. So that is gonna look something like this: a full tray with 1, 2, 3, 4, 5, 6, 7, 8, and then another full tray with 1, 2, 3, 4, 5, 6, 7, 8. So I've got 16, and then I've got 1, 2, 3, 4, 5. So 16, 17, 18, 19, 20, 21 altogether. So there are 5 cupcakes remaining. They're not put in the trays. Another question now. You and 7 friends, so you and 7 friends are calling a taxi service to take you home. In a taxi can fit 5 people. How many taxis do you need? So it's 8 of you. 5 can fit in a taxi, and there would be 5 of you without 1. So if you in one taxi would fit 5 people, but then we'd have 3 people left. So will you just take one taxi and leave out the 3 people? Or will you take 2 taxis where it would fit 10 people and it's 8 of you, so you can fit into that? So the answer should be 2 taxis. You can't say just 1 in this case. In this video, we'll learn to round numbers up to 100 to the nearest 10. When we go shopping and we've just spent £59, for example, and what we think in our head is that we've just spent £60, and then later on we might go and spend £31. So we normally think, oh, I've spent 60, another 30, that gives me 90 in total. So we're not using the actual amount, we estimating, or we're rounding this number and adding it together. We're adding these rounded numbers together. So how does that exactly work? If you spent £59, to the nearest 10, that is 60. So 59 is actually 55, 56, 57, 58, 59, 60. Yeah, so that is actually between £50 and £60. Why? Because I spent more than 50, but it's not 60 yet. So 59 stands between 50 and 60. Where exactly is it? So if you go through this, 51, 52, 53, 54, 55, so that's halfway through, 56, 57, 58, 59. So 59 is right here. So that is, as you can see, very close to £60. And that's why we say we've just spent £60 rather than 50. So 59 to the nearest 10 is 60. What about 58? Then again, 58 is here. So that is close to 60. So we're going to say to the nearest 10, that is 60. 57. Then again, that's again closer to 60 than it is to 50. So that's again to the nearest 10, that is 60. 56 to the nearest 10, again it is closer to 60 because there is 1, 2, 3, 4 places, whereas there are 6 to 50. So 56 again goes to 60. How about 55? 55 as well, although it's halfway through, we round it to 60. So 55 to the nearest 10 is 60. 54, that is rounded to 50. 53 as well is rounded to 50. 52 and 51 is rounded to 50. So if it's 55 and more, it's rounded to 60. If it's 54 and less, it's rounded to 50. So if the number ends in 0, 1, 2, 3, 4 or 5, then we round down. So we round 0, 1, 2, 3, 4, round down, which means in this case rounding to 50. If the number ends in 5, 6, 7, 8, 9, so 5, 6, 7, 8, 9, we round up. So 0, 1, 2, 3, 4, rounding down, 5, 6, 7, 8, 9, rounded up. So let's have a look at a few more examples. If I had 8 to the nearest 10, 8 is between 0 and 10, 0 and 10 like this, 0, 10. So 8 is about here. So to the nearest 10, that would be 10. If I have 2, for instance, which is here, about, to the nearest 10, that would be 0. So it stands between 0 and 10. It's not closer to 10, but it's closer to 0. So that would be 0. What about 12? 12 stands between 10 and 20. So it's closer to 10. And also checking the rule, it's one of these. So we're rounding down. That means we're going to 10. Let's say 35. Round it to the nearest 10. That stands between 30 and 40. And as I said, since it's 5 or above the last digit or the unit, in this case, that means we're rounding it to 40. Then let's have a look at 89. Then 9 is one of these numbers. That means you're going to round up. So, and also thinking of the position, 89 stands between 80 and 90. And it's definitely closer to 90 than to 80. So we round it to 90. So to recap, we round down if the units are 0, 1, 2, 3, 4. And we round up if the units are 5, 6, 7, 8, or 9. And my final question is, if we've got 60, rounded to the nearest 10. Now 60 stands between 60 and 70. So to the nearest 10, that is 60 itself. So the answer would be 60. So this is how you round numbers up to 100 to the nearest 10. We'll now look at a couple of examples of rounding numbers to the nearest 10 and how to check your answers using rounding. So we've got Hannah spent £18 on a bag and £43 on a pair of shoes. How much did she spend in total? So the key word there is total. And we know when we're looking for the total, we adding things together. So Hannah spent £18 on a bag and £43 on a pair of shoes. So how much is that in total? So we've got 18 add 43. So adding the units first, 8 and 3 makes 11. So I'll put 1 down and the 1 carried over. Now we've got 4 and 1 in the tens, which makes 5, and another 1 that makes 6. So she spent £61 in total. Now I've got to check the answer using a rounding. £18 to the nearest 10, that would be 20. £43 to the nearest 10, that would be 40, because it's closer to 40 than it is to 50. So I'll add to it 40. So both together, 20 and 40 makes 60. So is that close to the 61? That is very close to 61. So that proves that I've got that calculation right. So it's a way to check that my calculation is right. It doesn't have to be exactly the same, but it should be very similar. Now let's have a look at this one. Lisa had £50 in her pocket. So this is what she had initially. She gave her son £21. How much does she have now? So she had 50, gave away 20. How much does she have now? That we work out by writing 50, take away the 21 and finding what is left. So we need to take away 1 from the 0, but we can't do that, so we've got to borrow a 10 from the 5. So that is borrowing 1 to make this a 10. So the 5 becomes a 4. 10 take away 1 gives me 9. 4 take away 2 leaves me with 2. So she's got now £29. And I've got to check my answer using a rounding. So 50 is already rounded. I don't need to do anything about it. So 50. And the 21, that's about 20. So taking away 20 from the 50 leaves me with 30. That was 29. And my rounded answer is 30. So that is very, very close. That suggests that I did my calculation right. So this is how to check answers using rounding. In this video, we'll learn to recognize simple fractions of shape, like halves, quarters, and tenths. I'll start with halves. I've got a picture of a pizza here, which could be a real one as well. So what I have done is I've cut it into 2 halves. I folded the paper in half and I cut it. So both of these two are the same size. So I've got 1 half, another half, 2 halves. So one of these, this one, is a half. Both of them are halves. Notice how the spelling changes as well. So 1 half, 2 halves. 1 half, 2 halves. And one of them I show as 1 out of the 2. So 1 over 2. There are 2 possible. I'm taking just one of them. So 1 out of 2, that's read as a half, but also 1 out of 2. How can we find half of the shape? I've got a rectangle here. I could cut it in half by folding it first to be a bit more accurate. There we go. I've cut it into 2 halves. But I could have done something else. I could have cut it this way in half. So that's another rectangle that I've cut in half. And that's how it looks. That's still cut in half. So one of these is 1 over 2, 1 out of 2, a half. How can I cut a square into halves? That's one way. Or this is another way. Or I could cut it in half like this, because if I fold this, it's going to give me 2 equal shapes. A triangle, that's half of a triangle, and that's half of a heart shape. So halves are 1 out of the 2, so cut into 2 equal parts and you take one of them. We'll now look at a quarter. So again, I have a pizza which I've cut into 4 equal slices. So I've cut it in half first and then in half again. So one of these parts is a quarter. All of these together, they are quarters. So I've got 4 quarters in here. Here is a quarter, like quarter of an hour. So that is a quarter, 2 quarters, 3 quarters, 4 quarters. One of them, I write as 1 out of the 4 because I had 4 in total, 4 equal parts, and I'm looking at 1. I'm taking 1. 1 out of 4. 1 out of 4. So how do I cut shapes into quarters? So I have this shape which I cut in half before. What I'm going to do is I'm going to fold it in half again, the other way around, lengthways. So that has been cut into 4 equal parts now. So one of these is a quarter, this is another quarter, this is another quarter, and that's another quarter. So I've got 4 quarters. And this square in half and then half again. So each and every one of these is a quarter. So this is how you split shapes into quarters. We'll now look at tens. Again, I have another pita which has been split into 10 equal parts, 10 equal slices. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal slices. One of them each of these slices is called a tenth. All of these are tenths. So 2 tenths, 3 tenths, 4 tenths. So 1/10 is written as 1 out of 10, like this, 1/10. So if I separate this, this is 1/10 or 1 out of 10. How do I find tenths of a shape? So we've got tenths of a circle in there, a rectangle. So I could do it in different ways. I could split it into 10 equal parts like this, or 10 equal rows like this, or I could split it like halfway through and then about. So if they were all equal slices or equal parts of the shape, it would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one of these would be a tenth or 1/10. A similar thing would happen with a square. So I'd need to cut it into equal parts, just like the rectangle. So I could go there we go, and I have 10 equal parts here as well. And this is how you recognize and you draw and you find tenths of shapes. In this video, we're going to read, write and use decimals. We use decimals in everyday life, especially when it comes to money, liters, meters, grams or kilograms. So I'll start off with monies because it's easier to relate to it. So I've got a number of 10p coins in a row here. There are 10 of them, which means that all together they equal or make £1. So we start from 0 and we end with 1. What is one of the coins worth? That is 0.1 part of a pound. 2 of them will be 0.2. 3 will be 0.3. 4 will be 0.4. So 4 of them, 0.4. 5 will be 0.5 or half of it. 6 will be 0.6, 7 will be 0.7, 8 will be 0.8, and 9 will be 0.9, 10 will be 1 or a whole, because their value is worth 10p out of 100. So there we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and £1 finally. Now underneath the 10p coins, I've got 20p coins. As you can see, all of these are worth £1, just like the previous coins. So I will mark this as £1. And we'll start with 0 to end with 1. So what is a 20p coin worth, or what is it as part of a £1 coin? And that is actually 0.2, because 2 of these are equal to a 20p coin. Again, 2 of them to a 20p coin, 2 of these. So 2 of the 10p coins are equal a 20p coin. That's why we say 0.2. And 2 of these will be 0.4, because 20 and 20 makes 40 pence. And here we've got 0.6, and then 0.8, and finally 1 whole pound. Similarly, we've got 2 50p coins in here, which both together will make £1. So that is worth £1. So we start with 0 and we end with 1. What is each of these worth, or one of these? So that is 0.5, because it's 50p, so we got 0.5. But also we know that 0.5 is half of a whole. So 50p is half of £1. 2 of them make £1. So that means that when I write 0.5, that is read as 0.5. So we just read them in order. And 0.3, so 0.3 is written this way and is read as 0.3. 0.9. So that gives us some examples of how to read and write decimals. When else do we use decimals? We use them, as I said before, when it comes to meters. So if this length represents 1 meter, so that's 0 and that's 1 meter, so I'll write meter. Then up to this point would be 0.1 parts of a meter, 0.2, 0.3, 0.4, 0.5 or half of it, 0.6, 0.7, 0.8, 0.9 parts of a meter. And a similar story would be with liters, for instance. So let's draw this line again. So we're looking at a liter. Again, that would be 0.1 part of it, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Or if we are to compare them to the 20p, 2 of them, 2 parts would make 0.2. 4 would make 0.4. 6 would make 0.6. 8 would make 0.8. And 10 parts would make a whole litre. And finally, if we look at kilogram. So that means that we start with 0 and we end with 1, and this would be 0.1 part of it, 0.2, 0.3, 0.4, 0.5 for a half, 0.6, 0.8, 0.9, 0.6, 0.7, 0.8, 0.9, and finally 1 kilogram. So that is no different. In all these, we 1 part of the 10 was 0.1. So I hope this helps understand how to read, write and use decimals. In this video we'll learn to calculate money in pence. So we'll calculate how much different items altogether cost, writing the amount in pence using the correct money notation. So I've got 3 items, just like the ones that you'd find in a shop. Baked beans, which cost 43 pence, a ruler costing 35 pence, and sticky tape 16 pence. I want to find out how much these two will cost. So we've got 43 pence and 35 pence. Now the method I'll use here is by adding 40 and 30 first, which makes 70, and 3 and 5, which makes 8. So you could do this in your head as well. 70 and 8 gives me 78 pence. I need to write what it is. Is it pence? Is it pounds? So I've got to write the unit there. Now I will work out how much a ruler and sticky tape cost. So we've got 35 and 16 equals 30 and 10 gives me 40. 5 and 6 gives me 11. So 40 and 10 first gives me 50, and the one 51. Or 40 and 11 gives me 51. And what is that 51? Is pence. And finally, I'll try and add these all together. So I'll find the cost of all of the 3 items together. So we've got 43 pence and 35 pence. Now we work these out together here. So we've got these two costing 78 pence. And what is left is the 16. So if I add 16 to that, 70 and 10 is 80. 8 and 6 is 14. So 80 and 10, 90, and the 4, 94. So that is 94 pence all together. Now I want to take this one step further and show you how we'd write 78 pence using a pound in front, pound sign in front. So the way we write that is 0.78. So that 0 there means that there are no whole pound coins, and we've got 78 pence. 51 would be written as 0.51. I don't need a pence sign in there at the end now because I've got a pound sign in front, which tells us that there are no pound coins, and that decimal point separates the pounds from the pennies, so we know that the rest is pennies. So that is 51 pence, and this one would be written as 0.94. So this is how we calculate money in pence, but we also looked at how to write them with money notation, pence and pounds. In this video we'll learn to calculate money in pounds. I've got 3 different items here, just like the ones you'd find in a shop, and the Rubik's Cube costs £4. The pot for the flower for a desk costs £5. And treasury tags, a box of treasury tags, costs £3. So I will try and find how much costs to buy these two together. So that is £4, add 5, both together cost £9. If I get a treasury tag box as well as the pot of flowers, that would cost 5, and the 3 gives me £8. Notice how I put the pound sign in front to mean pounds. So pence come at the end, whereas pounds come at the front. Now I'll find out how much they cost altogether. So I looked at these two, they were £9, and the box 3. So 9 add 1 makes 10, and another 2 makes 12. So this is altogether they cost £12. Another way you might see them in is like this, especially in a shop like that, meaning they're £9 and no pence. And similarly for £8, as well as for the 12. So when you next see them in a shop, you know what they mean. In this video, we'll learn to read and write the date. We read the date every day. Maybe when waking up in the morning and checking the date in the phone, like it is here, 27th of May, or checking the date in the calendar. There it is. So it is May 27th, Monday. So if you don't know what day is it, but you know the date, then this tells me that it's a Monday. Or if you know that it is a Monday but you're not sure of the date, you know it's towards the end of the month, so that is the 27th. So today's date we'd write as 27th of May 2019. Another way to write it is 27th of May 2019. 27th of the 5th 2019, because May is the 5th month, January is the 1st, February is the 2nd, March is the 3rd, and April is the 4th, so May is the 5th. Also, with a 0 in front is absolutely right, so 27/05/19, which means the same thing, 27th of May 2019. One thing to be careful about or to be aware of is that in some computers or laptops you will see today's date as written as this, because in the American format you write the month first. Now you can clearly see that we don't have 27 months, so that is absolutely right for today's date. But with some other dates, that would be a bit confusing. So it is really worth checking which format your computer uses, and then maybe changing it to a British format. But these are just some common ways of writing the date, and the way we'd read them is 27th of May 2019, 27th of May 2019, 27th of the 5th 19, which this means 2019, and that means May. So I would not encourage you to use this format, just be aware of it existing, because this is the American format of writing the date. In this video we'll learn to read time in hours, half hours and quarter hours in analog clocks. This is an analog clock, the one that you hang on the wall. A digital clock is the one you see normally in your phones or alarm clocks. So we'll use an analog clock. As you can see, the clock has 3 hands. The short one, the shortest one, is the one that shows the hours. So if it's 2 o'clock, this will show the hours. That is 2 o'clock. And this is the longer hand is the minutes hand. Shows how many minutes past 2 o'clock this is. So this is just 1 minute past 2 o'clock. At this point that I'm going to show now, right on 12, that is 2 o'clock. So this would be 2 o'clock. And if I move this a full circle, the minutes will move as well as the hours. So it is now 3 o'clock, exactly 3 o'clock. And again, a full circle for the minutes hand, and it goes to 4 o'clock and then 5 o'clock and so on. So this gives you the exact hours. This gives you the hours, and if the minutes hand is on 12, that means it's exactly 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock and so on. The red hand is the seconds, so I'll ignore this for the time being. It tells you how many seconds passed. So we looked at exact hours. So reading time in hours. That was the 2 o'clock, 3, 4, 5 or 12 o'clock. Now half hours. What does that mean? When we move the minutes hand a full circle, that means it is 60 minutes, but because there are 60 minutes in 1 hour. So as you can see, this will move 60 minutes of 1 full hour. So the hours hand move from 5 to 6. So that is a full circle, which means 1 hour. If I move this minutes hand just half of the circle, so from that 12 up to the 6, this is also half an hour. So that 6 there means half an hour. This is the other half. So from 12 to 6, it's half an hour. So if you see the minutes hand being on 6, that means that in this case it is 6. The hours, that is 6. And the minutes is half an hour or 30 minutes. So this is 6:30 or 6:30. And this is 7 o'clock. Now this is 7:30. This is 8 o'clock and this is 8:30. This is 9 o'clock and this is 9:30. So when you see the minutes hand on the 6, it means half past. So this is now half past 9. It's past 9, so it's half past 9, half an hour past 9, which is 30 minutes past 9. So that explains half an hour. But what is quarter an hour? Quarter, as we've looked before when we looked at fractions, half looked like this. And quarter looked like this. So this is a quarter, this is a quarter, this is a quarter, and that is a quarter. So quarter an hour is this quarter turn, from 12 to the 3, from 3 to the 6, from 6 to the 9, from 9 to the 12. So this is 10 o'clock now on 3, because this is quarter a turn or quarter an hour. We've got quarter past 10, quarter past 10. So another quarter an hour, and then it goes to half past 10. Now another quarter, and how do we read this? We read this as quarter to 11. So it's close to 11. It's nearly going to be 11 o'clock, but it's not yet, as you can see. It's not yet there. How long does it take? Quarter an hour to get to 11 o'clock. So we need another quarter turn or quarter an hour to get to 11. So read that as quarter to 11. Now that was 11 o'clock and it's past 11. It is, at this point, it is quarter past 11. So past 11, quarter an hour past 11. And here it is half past 11. So it's past 11, as you can see, not 12 yet, and it is half past 11. And now this is not 12 yet, but it is quarter to 12. It needs a quarter to get to 12, a quarter an hour to get to 12. And this is then finally 12 o'clock. So we've looked at hours, 2 o'clock. We looked at half hours. So when it's on 6, the minutes hand. So we had 9:30 and 10:15 and 11:15. So a final bit that I'm going to do is I'm going to show these once more on the clock. So 2 o'clock. That suggests it's exactly 2 o'clock. It's just hours, no minutes, and the hours hand goes to 2. So I will take the hours and to 2. There we go. So 2 o'clock. 9:30. So we know it's 9, but it's past it by half an hour. So we'll go to 9 first. So there we go. We've got the hours hand on the 9. That is 9 o'clock, but it's actually passed by half an hour. So that is half an hour. And there we have 9:30. 10:15. So it is 10 o'clock, but quarter past. So there we are. This is 10 o'clock. Now quarter past. Quarter an hour past the 10 on the 3. And finally, quarter to 11. So it needs quarter an hour to get to 11. So we are on 10 already, and that's not in 11 yet, but it's got to be just quarter an hour. Quarter. And that's it. So not 11 yet, it needs quarter an hour to get to 11 o'clock. So this is how to read time in hours, half hours and quarter hours in analog clocks. In this video, we'll learn to read hours from a 24-hour digital clock. We come across digital clocks when it comes to smartphones or alarm clocks like this one. So you see time written in digits rather than having a circular clock with clock hands. So 0, 0, 0. That means it is the start of the day, which is 12 midnight. Now, this is 1 o'clock in the morning. This is 2, and then this is 3, 4, 5, 6 o'clock in the morning, 7, 8 o'clock, 9, 10 o'clock, 11, and this 12 here is midday. And then we go into the afternoon, so that is 13, which is the same as 1 in the afternoon or 1 p.m. And then 14, 15, 16, 17, 18, 19, 20, 21, which is the evening, 9 in the evening, 22, 10 in the evening, 23, 11 in the evening, and we go back to 0, which is midnight. You sometimes might see these times with an added 0. So 0, 0, 0, 0. It still means the same thing, the same time. 0, 1, 0, 0, 0, 2, 0, 0. Sometimes read as 0, 200. But it still means the same time. That is 2 in the morning. And that is 12 because there is a 1 there, so I don't need to put a 0 in front of this. So it has 2 digits, 2, 2 and 2. So this is how to read hours from a 24-hour digital clock. In this video we'll use the metric measures of length: millimeters, centimeters, meters and kilometers. Metric measures, as you can see, they have a pattern in the way that they've said. Millimeter, centimeter, meter, kilometer. They have the word meter in them, just like metric. They are different from the imperial measures, such as inches, for instance, or miles. I will look at these in turn. Millimeter is a really tiny, short length. So looking at a ruler, millimeters are represented by these very small lines. So as you can see, they are rather tiny, and every ruler has them. So that helps you remember very small lines. I've tried to cut a piece of string that is about 1 millimeter. It's not absolutely accurate, but it gives you an idea. Something to help you remember is that a millimeter is about the width of a fingernail. So if you turn your finger this way, you can see the nail, and the width of it is about a millimeter. So very, very small. Centimeter, that's the short form and that's the long. So C is for centi and meter, M for meter. I've again cut a small string about 1 centimeter. So this is 1 centimeter. The longer lines, represented by the longer lines here. So there you go, you've got that 10 in there to show it's 10 millimeters. So 10 millimeters make a centimeter, and if I turn it this way, I can clearly see centimeter, so that's 1, that's 2, 3, 4, 5 and so on. That's about the width of the finger. So if I try and place my small finger on the ruler, I can see it's about 1 centimeter. Meter is a bigger unit. That is about from the tip of the finger to the tip of the shoulder on the other side. So if you try and place a string, that's how long it is about. So this is the shoulder, this is one arm, and this is the other. So from the tip of the finger on one side to the shoulder on the other side, that is how long about is a meter. So I've tried to cut this string. That is 1 meter long. And after the meter, a bigger unit is the kilometer. So K is for kilo and M is for meter. Kilometer measures the distance, so it's not short, it's much bigger. So we're looking at distance between two places. So the distance you can walk in about 10 minutes. So if you walk at a normal pace for about 10 minutes, apologies, for about 10 minutes, that's how long a kilometer is. So it could be perhaps the distance from your home to the nearest shop that you have, or to a school, or to the GP, to the doctors. So that is about the distance of 1 kilometer. So these clues that I've given you would help you estimate how long something is, or what is the distance between one place and another. And the other thing that I'd like to stop at is actually how many millimeters make 1 centimeter. And that a ruler can help you with that, because when we looked at millimeters, I said they're the tiny amounts and the longer line represents the centimeters. So there are 10 millimeters which make 1 centimeter. And if I turn this around, that kind of approves what I've just said, because as you can see, the long line now marks 1 centimeter. So 10 millimeters are equal to 1 centimeter, and a ruler can help you with that. Now, how many centimeters would make a meter? And maybe a ruler wouldn't be long enough to show you that, but measuring tapes can. So I'm gonna use a measuring tape to show you that. So we'll start with 0. We've got it on the centimeter side because it could be on the inches as well, and we're talking about centimeters rather than inches. So we start from 0, and that goes up to 100. So that is how long a meter is, 100 centimeters. So 1 meter is equal to 100 centimeters. A clue for that is also the prefix centi, which is like a century, and there are 100 years in a century. Or cents in a euro, there are 100 cents in a euro, so that helps you remember as well. And I will look at how many meters there are in 1 kilometer. So a kilometer is made by 1,000 meters. The word or the abbreviation K in there, km, we use K in everyday life to mean 1,000. So 2K subscribers, or I spent 5K in this car to buy this car. So that is K to mean 1,000 meters. So in 1 kilometer there are 1,000 meters. So I hope these clues help you remember, and also ordering them. As you can see, they're from the smallest to the largest. In this video we'll learn to use metric measures of weight. We've got grams and kilograms. So again, just like the other units we looked at, we've got gram, kilogram, the word gram repeating itself in the metric measures. So this is not the same as pounds, for instance, or stones, which are imperial measures. So G stands for gram, K stands for kilo, so kilogram. Now we'll look at how much is actually a gram. So I've got a few grains of salt in here, and that is how much a gram is actually. So just a few grains of salt. So we measure medicine in grams as well, just like the milliliters. So when you get medicine, it will tell you how much it actually weighs, how many milligrams it is. So a paracetamol tablet is 500 milligrams, and this is, so 2 paracetamol tablets will make 1 gram, which is what this is. So it's about 2 paracetamol tablets. So I'll write that down to help us remember. 2 paracetamol tablets weigh 1 gram. And a kilogram is the weight of a bag of sugar, or a bag of pasta, or sometimes flour. So it tells you here it's 1 kilogram. What we use to measure ingredients is a scale. Sometimes, well, when it comes to ingredients, it's a kitchen scale. So we'll look at what this is going to show. So I'm going to try and place that in. So I've got to change the unit. I've got, right, see, we've got to restart it, and I'll take it off the scale and turn it on. We've got the right units, which is kilograms, so grams and kilograms. So if you look at it, it is 1,000. It's about 1,000, which is how much a kilogram is. So this weighs a kilogram, and 1 kilogram is actually 1,000 grams, as the scale shows. Again, like we said before, that K in there helps you remember, because we say K to mean 1,000. So I've got 2K subscribers, or the car cost me 20K. So that means there are 1,000 grams in a kilogram. So if you replace it with 1,000 in there, so 1,000 grams, K means 1,000. And that hopefully will help you remember how many grams in a kilogram. You'll hopefully remember that gram is smaller than a kilogram, and a gram is equal to or weighs as much as 2 paracetamol tablets. A kilogram weighs the same as a bag of sugar or a bag of pasta or a bag of flour. In this video we'll learn to use metric measures of capacity, milliliters and liters. So, as we said before, metric measures are different from the other measures like imperial, an example of which is ounces. As you can see, milliliters and liters, they have the word liter in there, liter, which sounds like meter as well. So that's where the metric comes from. Milliliter, so that's the short form. M stands for milli and L stands for liter. We measure in milliliters medicine, so or very small amounts. Maybe oil you're going to put when you cook, how much oil you're going to put. So milliliters, I'll show you a milliliter. So here is how much a milliliter is. So there we have 1, 2, 3, 4, 5 milliliters. So you administer medicine with this, and that is how much a milliliter. So it's a really small amount, a milliliter. So I'll empty that 1 milliliter now into a teaspoon, and you can see how much it actually fills, and I'll add another 1, so that is 2, and the spoon is nearly filled, because you actually need 2.5 milliliters to fill a teaspoon. So I've added just another half, so that gives you 2.5. So that helps when giving children medicine or taking medicine yourself. So that should help us remember how much is a milliliter. So medicine, 2.5 ml is 1 teaspoon. Whereas a tablespoon like this will be filled with about 5 milliliters. So let's try that out. I will fill this with 5 ml. So I've got 5 ml in the syringe, and I'll empty that. So it's roughly about 5 ml. So I'll add that as well. So 5 ml makes a tablespoon. And now moving on to liters. Liters are much bigger than milliliters, and we've got liter bottles as well. This is a 2-liter bottle, and it's filled halfway through. So this is half full, and that makes 1 liter. So that helps us remember as well. So water bottle is about 1 liter. And I will try and write some clues to help us remember now how many in each of them. So milliliter, that is a very small amount. milliliter, not millimeter. So I'll change that to milliliter. There are 1,000 milliliters in 1 liter. So 1,000 milliliters makes 1 liter. So that's what you've got to remember. And since milliliters are very small amounts, you need 1,000 of them to make a liter. So if you tried to fill with the syringe with this amount, trying to fill lots of this into a 1 liter bottle, you'd need 1,000 of them. So a milliliter is much smaller than a liter, and these clues about medicine, medicine being in small amounts will help you remember how much there is in a milliliter. And liter, we've got water bottles or Coke or whatever you drink, or orange juice. So liter bottles, have a look at them and try and use those to estimate the capacity of other objects or other containers. And how do we actually measure the capacity? And that is through measuring jugs. So they've got marks on them, like the bottle, and it shows how much there is in each and one in each of them. Or like I showed you with this syringe, we've got milliliters of medicine or water in it. In this video, we're going to read and compare positive temperatures. You've probably seen thermometers like this. A weather thermometer looks pretty much like this, where you've got temperatures going up degrees Celsius in degrees Celsius. So if you can read the temperature currently, that is in between 20 and 30, so that is 25 degrees Celsius. So I'll write that down. 25 degrees Celsius. So that's the short form for Celsius, and that's the degree symbol. So this is 25 degrees Celsius. It's supposed to be a weather thermometer. And at this point, this is 0 degrees Celsius, and this is 10 degrees Celsius, this is 20 degrees Celsius, this is 30 and 40 degrees Celsius. This is very hot temperature. Some countries in Africa or Asia, that's where this temperature is reached in the summer. In the UK, that's very uncommon in the summer. And this is 0 degrees Celsius. This is the point where the water freezes. In the winter, if you reach this temperature, it will be frosty outside. And this is the temperature when the water freezes. This is even colder, but we're not going to look at those at this time. So what temperature will this be? This is between 0 and 10. So this is 1, 2, 3, 4, 5. This is 5 degrees Celsius. This is 6, 7, 8, 9, and then 10. So this is between 10 and 20, 15. Between 20 and 30, 25. Between 30 and 40 is 35 degrees Celsius. So as you go up, the temperature will be higher. So this is 5 degrees Celsius. And is that hotter than 0? Yes, because it's higher in the scale. So that is hotter than 0 degrees Celsius. And let's compare some other ones. Look at 20 and then 15. Again, 20 degrees Celsius is hotter because it's higher in the scale than 15 is hotter than 15 degrees Celsius. And if we're trying to compare 25 with 30, so there is 25 compares with 30, so 25 degrees Celsius is colder than 30 degrees Celsius. So that kind of compares the temperatures. If you think or imagine a weather thermometer, there is 0 and temperatures go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So the higher the number, the higher the temperature. Very similar to this is the body thermometer. This is, you measure your body temperature through this when you're unwell, when you're feeling unwell. And let's have a look. This is currently 36.5. I'll show that once more. 35.6, 36.5. So it's around 36 degrees, the body temperature. About 36 degrees it should be. If it's maybe 38, that would be considered high temperature. 39, 40 or 41, that's very dangerous. 40 and 41 are dangerous body temperatures. So anything around 38, you need to go to the doctor to get it checked. So this is how you read and compare positive temperatures. In this video, we'll learn to read and use simple scales to the nearest labeled division. If you look at these kitchen scales I have on my hand, there are some different numbers which mean different things. On the outside, we've got these divisions. We've got starting from 0 and going to 200, 400, 600, 800 grams, 1 kilogram and so on. Now we have on the inside, we have pounds. So there is 1 pound, 2, 3 and so on. There are some smaller divisions in between the big numbers that we can see. But we're not going to be too worried about those in this video. What we're going to be looking at is seeing what is this mark closer to? Is this closer to 0 or 200? If you're looking at grams, and it is closer to 200 grams. So to the nearest labeled division, this weight is 200 grams. This is 400 grams. So close to or about 400 grams. This is about 600 grams. This is about 1 kilogram. And this one here is about 1 kilogram and 400 grams. This is about 2 kilograms. In terms of pounds, this is close to 8 ounces. So it is closer to 8 ounces than it is to 1 pound. Now it is closer to a pound than 8 ounces. And this one here is closer to 2 pounds. So this shows how to read unused scales to the nearest labelled division. And another type of scale is the one used in a ruler. We've got centimetres and millimetres, as we've said before. What you have labelled, however, here is only centimetres. So you've got 0, 1, 2, 3, 4 centimetres. I'm going to try and measure this clock. So one side of it, as you can see, is not exactly 7 centimetres, but to the nearest label division it is 7 centimetres. So it's closer to 7 than it is to 6. So I could say that this is actually 7 centimetres. And if I try and measure this thermometer, one side of it, this is again a bit less than 5 centimetres, but I'm going to say to the nearest label division this is 5 centimetres. So what is important to remember? You've got to look at which one of the numbers that you've got there the measurement is closer to. So it was between 5 and 6, for example. If it's closer to 5, then you say it is 5 centimeters or kilograms. If it's closer to 6, then we say it is 6 centimeters or kilograms, depends on what you're measuring. In this video, we'll learn to recognize and name 2D shapes. At entry 1, we looked at these 4 shapes at the top: rectangle, triangle, square, and circle. If you need to revisit these, or you can't remember, or you can't recognize these shapes, then revisit the entry 1 video on 2D shapes. The extra shapes you need to know at entry 2 level are these 2. This, what does it look like? It looks like a house, doesn't it? So I will move to a penthouse, because the name for the shape is actually Pentagon. Penthouse, Pentagon. So this is called a pentagon because it has 5 sides. So we have 1, 2, 3, 4, 5 sides. That's why we call it a pentagon. Another way to remember this is through a pen, which you need 5 fingers to hold it. So 5 fingers, 5 sides, and that's a pentagon. And this other shape has 1, 2, 3, 4, 5, 6 sides. We call it hexagon. So 6 has this X, and hexagon has an X there as well. So that should be a clue to help you remember that a hexagon has 6 sides. So these are the 2 extra 2D shapes that you need to remember, need to recognize and name at entry 2. In this video, we'll learn to recognize and name 3D shapes. At entry 1, we looked at one 3D shape, which looked like this. And we call that a cube. So this is a Rubik cube, and the name of the shape is actually a cube. Like the sugar cubes, like the ice cubes. All of these faces are the same. All of these lengths are the same. So I'll write next to it or underneath it, cube. Next to it is something which is very similar. Another shape which looks very similar to a cube, but some sides are actually longer. Not entirely the same, not exactly the same, like they are in the cube, but they are longer. So these are longer than these. This is just a box, and most of the boxes have this shape. They are cuboids. Cuboid. So the names are very similar as well. Cuboid is longer, just as these are longer as well. The next one we'll look at is this shape, which we call a pyramid, like the pyramids of Egypt. A pyramid is pointy at the top. So pyramid, pointy. That should help you remember it. And also pyramids of Egypt. The other shape that we've got here is a cylinder. Cylinder. You can see circles, both sides, circles, cylinder, circle, cylinder. And finally, we have this shape which we call sphere. So it is like a circle. The sound links to a circle, because if you were to draw this, it's going to look like a circle as well. But this has the shape of a ball. It's three-dimensional, so it's like a ball. This is an anti-stress ball, and it's got a smiley face on. So perhaps that smiley face, which begins with S, like the sphere, might help you remember. Smiley, sphere. Cylinder, circle. So circle on both sides, and that L is there to show it's long cylinder. So you wouldn't confuse it with a sphere, which has a smiley face on. So these are some clues to help you remember the names of these shapes and recognize them. In this video, we'll look at describing the properties of 2D shapes. What we'll look at is the sides, corners and angles. So we'll try and describe the sides, corners and angles for each of these shapes. So let's start with a rectangle. How many sides does this rectangle have? Well, I can see one here, so this, and another here, 2, 3 and 4. So it has 4 sides. How many sides does a triangle have? It has 1, 2 and 3. So 3 sides. And the square has 1, 2, 3 and 4. A circle, since it's not a straight line, it has no sides. So 0 sides. A pentagon has 1, 2, 3, 4, 5. A hexagon has 1, 2, 3, 4, 5, 6. Now we'll look at corners. How many corners? The corners are the ones that are created where the two sides meet. A bit like the corners of a room in your house. So that is a corner. Here. This is a corner. That's a corner. That's a corner. So we have 4 corners. In a square as well, we have 1, 2, 3, 4 corners. In a triangle, we have 1, 2, 3. In a square, there is no corner. In a pentagon, we have 1, 2, 3, 4, 5. In a hexagon, we've got 1, 2, 3, 4, 5, 6. What do you notice? 4 sides, 4 corners, 3 sides, 3 corners, 4 sides, 4 corners, 0 sides, 0 corners, 5 sides, 5 corners, 6 sides, 6 corners. So the number of corners matches the number of sides. So if you remember that a pentagon is like a penthouse, it has these 5 sides. That means that you can remember that it has 5 corners as well. A hexagon has 6 sides and it has 6 corners as well. Now the next thing we'll look at is the angles. What type of angles does this have? Now there is a special type of an angle which is called a right angle. Or a 90-degree angle. It means the same thing. That type of angle is the one typically created in the corners of a room, like this. So this is a right angle, or created by paper. The A4 pieces of paper that you might have, or smaller versions. So that if I try and fit this into the corners of a rectangle, that would fit in exactly into place. And same thing over here as well. So that means that a rectangle has right angles. And if you look at the square, it also has right angles. So this has right angles as well. If you look at a circle, since it has no corners, you really can't fit any of these, so it has no angles at all. So 0 angles. Or no angles. And if I try and fit this into the triangle, I can't really, in this type of triangle, I can't really fit this. So let's see how that looks. So it's not a right angle really, this one. It's smaller than a right angle. If you try the next one as well, it's not like a right angle, it's smaller than. And the other one as well, it's smaller than a right angle. So this type of A triangle has smaller than 90 degrees. Let's have a look at this particular pentagon, because there are many different ones. It could be, this could be a pentagon as well, so which looks slightly different. So for this particular one that we have, we've got some right angles, and we've got some angles which are bigger than 90 degrees, as you can see. So bigger than a right angle. And that is definitely. So this has different ones, has 90, has right angles and others as well. And if we look at a hexagon, let's try and fit this in. That is definitely bigger than 90 degrees. And this is bigger than 90. And this is bigger than 90. So bigger than a right angle, bigger than a right angle, bigger than a right angle. So these are bigger or greater than a right angle. This has bigger and right angles, this particular shape. So knowing how or what the right angle looks like helps you identify what type of angles these shapes have. Do they have right angles? Are they smaller? Are they bigger? So again, a right angle is an angle that looks like this, like the corners on a piece of paper, or like the corners in a room. So we've looked at the properties of 2D shapes. In this video we'll learn to describe the properties of cubes, cuboids, cylinders, pyramids and spheres. You probably recall that we call these 3D shapes, or three-dimensional shapes. Looking at a cube, the faces are the ones that we see when we turn the shape around. So this is one of the faces. They're normally flat. So we've got 1, 2, 3, 4, 5, 6. So there are 6 faces in a cube. What about a cuboid? Is it the same? So we've got 1, 2, 3, 4, 5, 6. So it's exactly the same, because cube and cuboid, they are very similar shapes. The only thing that changes is the length of some of the sides. There we have a pyramid. So the pyramid has 1, 2, 3, 4, 5 faces. So this is a square based pyramid, because a triangular based pyramid would have 4 faces. So this has 5 faces. What about the cylinder? We can see 2 of them, one at the bottom and one at the top. And there is one that goes around, so there are 3 faces in total. Sphere, one that goes around, continuous throughout for the whole shape, so there is 1 face. Edges, what are the edges? Edges are where the 2 faces meet together. So this is the edge, this is the edge, and so on. How many edges does a cube have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 edges. Is it the same for a cuboid? There we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is the same for a cuboid as well. How about the pyramid? So we have 1, 2, 3, 4, 5, 6, 7, 8. In a cylinder, we've got 1 and 2 circular ones. How about the sphere? As I said, there is one face that goes around that you can see, so there cannot be two faces meeting together. Therefore, there are 0 edges or no edges. And another thing that you might come across is the corners or the vertices. Corners, there is a corner formed there, 2, 3, 4, 5, 6, 7, 8. So there are 8 in a cube. How about a cuboid? We've got 1, 2, 3, 4, 5, 6, 7, 8. So again, the same number. In a pyramid, square-based pyramid, we've got 1, 2, 3, 4, 5. 5 corners. In a triangular-based pyramid, it'd be 4 of them. Do we have any corners in a cylinder? No, we don't have any corners at all. And there is none in the sphere as well. Like the corners of a room. So 0 corners and 0 corners. The final thing we'll look at is the base. The base is the face that the shape sits on. So at the moment, this cube is sitting on this face. So that is the base of this cube now. But I could turn this around and then this would be the base. This would be the base. So it's what it's sitting on. And what shape is the base? It is a square because it's got equal sides. So even if I turn it around, this base would still be a square because all of the sides are squares in a cube. So that is the shape that it has, square. The base of the cube is a square. What about the cuboid? As you can see, this is a rectangle. Even if I turn it this way, it'd be a rectangle. So it is a rectangle, but sometimes a cuboid could be made of squares and rectangles. So you've just got to bear that in mind. And square-based pyramid, as the name suggests, is square-based. The base is a square. Triangular-based pyramid is a triangle. And when it comes to a cylinder, as you can see, the base is a circle. Even if I turn it this way, that would be a circle. And when it comes to a sphere, obviously the sphere has no base. It's very difficult to have it sitting, so there is no base for it. In this video, we're going to extract information from lists. We use lists in everyday life, especially when it comes to prices. So we've got a price list. Sometimes we have a list with opening times, days of the week. So in this example, I've got prices from a takeaway shop. So we've got burger costing £2, chips costing £1, and pizza costing £5. The kind of questions you could be asked about this information are different, vary. So I'll just look at a few examples. How much does a pizza cost? So you'll go and look, where is pizza? There it is, £5. So your answer should be £5. Which item is the cheapest? So if you look at them, the cheapest, that's 2, this is 1, and this is 5, so 1 is the cheapest. So I'll write that item is chips. Then we've got how much more than a burger does a pizza cost? So how much extra, how much more? So we're looking at a burger and a pizza. So that is £2. So we go 3, 4, 5. So £3 more. How much does a burger and chips cost? So burger and chips, that was 2 plus the 1 equals £3. So these are just some of the, some examples of the questions that you might be asked. In this video, we're going to extract information from tables. We use tables in everyday life to show information about prices, opening times. An example that I've got here is about height. So I've got the names of children in a family and their corresponding heights. So we've got Anne is 86 centimeters tall, Sue 105, and Ben 98 centimeters. So the kind of questions that you may be asked about such information vary, but I've included a couple of them. So we've got how tall is Sue? So look at the name Sue. There is Sue, who is 105 centimeters tall. So 105 centimeters. I've got to include the unit at the end as well. Who is the tallest? And out of these, if you look at the height, we've got 86, 105 and 98. So these two are below 100. This one is over 100. So that is the highest, and that is the tallest as well. So 105 centimeters. That is, the person is Sue. You could just write Sue as well and leaving out the 105 centimeters. So I will actually take it off. So who is the tallest? That is Sue. How much taller than Anne is Ben? So we're looking at Anne and Ben and we're comparing 86 with 98. So how much extra? How much taller? So 86, 98, so this is higher, so I'm going to have to take away that. So I've got 98 and I'll take away 86. So we got 8, take away 6 leaves me with 2, 9, take away 8 leaves me with 1. So that is 12 centimeters. 12 centimeters. But before I move on, I would like to check that I've got this right. So I've got 12 centimeters. If I add that to 86, so I'm doing the opposite to check whether that gives me 98. So 2 and 6 gives me 8, 1 and 8 gives me 9. So my answer was right, because when I add that to 86, it does give me 98. So the difference between them two was 12 centimeters. So these are just some of the examples, but there could be other questions as well. In this video, we'll learn to extract information from a tally chart. Here we've got a tally chart that I've drawn. It is about items sold in a charity sale. We've got cupcakes, milkshakes, fruit bowls and chocolate bars. The number of marks here tells how many, or shows how many of each item were sold. So we've got 1, 2, 3, 4 marks, which suggests there were 4 cupcakes sold. We've got 1, 2, 3, 4, 5, 6 milkshakes sold, and we've got 1, 2, 3, 4, 5 fruit bowls sold, 1, 2, 3 chocolate bars. Here we have 3 questions that you could be asked about this tally chart. Just 3 examples. How many milkshakes were sold? So we'd go to the items and we'd stop at milkshakes. How many were there? There is 1, 2, 3, 4, 5, 6. How many more fruit bowls than chocolate bars were sold? So we're comparing fruit bowls with chocolate bars. How many more? How many extra? So there are 3 here, but there are 1, 2, 3, 4, 5. So there are 2 extra, 2 more. 2 more fruit bowls than chocolate bars. How many items in total were sold? So I can see that there is a block of 5 here and another block of 5 there. So that's easy to count. And there is 4, and this one makes 5. And the 5, 10, 15, 16, 17, 18. 18. You could add them in other ways as well, and it doesn't matter as long as you get this result, because different methods are absolutely fine. So this is how to extract information from a tally chart. In this video, we'll learn to extract information from bar charts. You've probably seen bar charts before, and this is an example of it. This one shows information about the items sold in a charity sale. We've got the number of items on one side, so from 0, 1, 2, 3, 4, 5, 6 and 7, and which items were sold as well at the bottom. So we've got cupcakes, and there were 4 of them, milkshakes 6, fruit bowls, there were 5. The type of questions that you might be asked about this vary. Here are just 3 of them, just examples of 3 of them. How many fruit bowls were sold? So we're looking for fruit bowls. There we go, fruit bowls. There were 5 of them were sold. You might find it useful to draw a line as well and match it with a number if you are unsure. So there were 5 of them. Which was the most popular item? So the most popular item, as you can see, because this is the highest bar, which means there were more milkshakes sold than there were fruit bowls or cupcakes. So we've got 6 of them, and that item is milkshakes. Three chocolate bars were also sold in the sale. Show this in the bar charts. So we haven't got chocolate bars, and we'll need to add it. So I will add it here. So we've got chocolate bars, and there were 3 of them. So we'll go up 1, 2, 3. So up to 3. And that same width for all of these. So there is just one square width, and I've left a gap throughout in between the bars. Now I'll colour it in just like I have done with the other bars. And then we have 3 chocolate bars. So these are just some of the questions that you could be asked about a bar chart, and a bar chart can be about other things as well in life. So maybe it could be to show how many items were sold in a shop. It could be different ages of groups of people. It could be what people travel by. Do they use the public transport like trains and buses? Do they take the bike? So do they ride the bike to the school, or maybe they walk? So this could be shown as well at the bottom, and how many in each class, for instance, take the bus, ride to school, and so on, cycle to school. In this video, we'll learn to make numerical comparisons from bar charts. We'll have a look at what that means in a second. But as you can see, I've got a bar chart here which is about items sold in a charity sale. So I've got different items: cupcakes, milkshakes, fruit bowls, chocolate bars, and how many of each were sold. Now here we'll make some numerical comparisons. How many more fruit bowls, so how many extra fruit bowls than chocolate bars were sold? So we're looking at fruit bowls and chocolate bars. How many more, how many extra? We've got, there are 3 chocolate bars and there are 5 fruit bowls. So there are 2 extra or 2 more. If you want to show the working out, you could do 5, take away the 3 equals 2. But all you need is that 2 there. How many more milkshakes than cupcakes were sold? So we're looking at milkshakes and cupcakes, comparing them. There are more milkshakes, so we've got 4 and then 5 and 6, so there is 1, 2. Again, 2 more. Again, let's do the working out. So it's 6, take away the 4, gives me 2. So this is how you make numerical comparisons from bar charts. In this video, we'll sort items using 2 criteria. So looking at these shapes that I have here, what is different about them? I can immediately spot that there are 2 colors. So that's one way to sort them. So I'll sort them into blue and pink. Right? So I've got blue and pink. Now I can also see that these shapes are not exactly the same. So I've got circles and squares. So I could sort them as well based on that. So I'll separate circles from the squares. And I'll do the same on the other side. So what I have here is pink circles, and here I have pink squares. We have blue circles and here I have blue squares. So I've sorted these items using 2 criteria. One was the color, so I've split them into pink and blue, and the other one was the shape. So I've got circles at the top and I've got squares at the bottom. So to sort items using T criteria, you've got to look at what is different about them. So make that first sort, just like I did. I split them by colour first, and then notice the difference within the colours. So I could see then that there were circles as well as squares, and that's how I sorted them the second time, using the second criteria. In this video, we'll learn to take information from one format and represent in another format. So what this means is that you might take information from a list and represent it in a tally chart, take it from a table and represent it in a bar chart. What I'm going to be doing is I'm going to take information from a list and we'll put that in a table, then a tally chart, and finally a bar chart. So what I have here is information from one class on how they travel to college. So I've gone around and I've asked a class how they actually travel to college. Do they take the bus? Do they travel by car? Do they take the train? Or do they walk? So I will represent that now to begin with in a table. So what are the possible ways of traveling, the modes of travel? So we've got bus, so I'll add a row with bus. Car is another one, then bus, bike, walk, and that's it. So I haven't got any trains, nobody said train. We've got bus, car, bike and walk. So that's the 4 of them. And here I'll include the number. So we've got bus 1, 2, 3, 4, 5, 6. So there are 6 who travel by bus. And car, we've got 1, 2, 3. 3 people travel by car. Bike, 1, 2, 3. And walk, we've got 1, 2, 3, 4. So what is this? That's the mode of transport. Mode of transport. And that is number of learners. And this shows how to represent them. Finally, we could add at the bottom the total. So we've got 6 and 4, which makes 10, 13, 16. I could have also added these two, 3 and 3 makes 6, so 10 and 6 makes 16. So this is how you represent this information in a table. Now I will show the same information in a tally chart. So I've got the table I created before with modes of transport, bus, car, bike, walk, and the number of learners in the other column. Now, tally chart, as the name suggests, you actually draw tallies or marks in there. So instead of this number 6, I'm going to have marks, 6 marks. So 1, 2, 3, 4, 5, 6. So we always make a block of 6 like this. So we do the first 4 marks straight, and then we draw across another mark to make 5 of them, and then there is the next one to make 6. In this way I can read a block of 5 very quickly. I don't need to count the marks, the tallies. So now car, there's 3 of them, so I'll go 1, 2, 3, and the same thing with a bike. 1, 2, 3. Walk, there's 4 of them. 1, 2, 3, 4. We don't normally have a total in a tally chart unless you have an extra column here with the numbers. So I'll leave that out for the time being. Now I'll try and show the same information in a bar chart. So I will draw bars to represent how many learners take the bus or walk, cycle, and so on. So what I'm going to be starting off with is actually drawing a vertical line like this and a horizontal line next to it, so they both meet at this point, which is where 0 comes. And then normally we put the numbers in there. So let's have a look. We said we had 3 who traveled by bus, so there was bus 3, and there were bus 1, 2, 3, 4, 5, 6. So 6 traveled by bus. There were 3 who traveled by car, and we had bike 3 and walk 4. So I can double check here to make sure that the information is correct. So what I'm going to be doing, I'll put these modes of transport here at the bottom and the numbers alongside it, so that we can see how tall the bars are for each of these. So we've got bus, car, bike, and walk, and the numbers will go up. The highest it goes is 6, so let's see if I can do them going up in 1. So 1, 2, 3, 4, 5, 6, and that's exactly it. So that is a good idea. 1, 2, 3, 4, 5, 6. If I didn't have enough space, I might think of going in jumps of 2, so I'd have 2, 4, 6, 8, and so on, but that's not needed here. So what I'm going to be doing now, showing how many travel by bus. So we've got bus, that's 6. So I'll go 1, 2, 3, 4, 5, 6, showing that here. Now you could color this in or draw lines in it, however you wish. I'll go for the lines because it's easier. Then we have car 3, so 3 people traveled by car. Three ride bike to class or cycle. And we've got walk, there is 4 who walk, so there is 4, there we go, and that is done. I've left a gap in each of these and that gap is the same. I can't have 2 squares gap here and 1 there. That gap is 1 square throughout. But I could have it without gaps as well, and that's perfectly fine, but all of them would need to be without gaps. And right, so what does that show? 0, 1, 2, 3, 4, 5, 6. What does that mean? That is number of learners or number of people. And bus, car, and bike and walk, that is modes of transport or modes of travel. And what does this represent? And that is information from one class on how they travel to college. So I could write it here. So how learners in one class travel to college. It's really important that the title summarizes what the bar chart is about, and we shouldn't forget the numbers, what they mean, and those at the bottom, which is the modes of travel in this case. So we need to include every one of these that is in there, and the bars need to go up to how many learners there are who travel by bus, car, bike. So that should be representing those.